So, I was going back over some of the material from Stanford's deep reinforcement learning course, and it really got me thinking. When you're in the lab, everything seems to work perfectly. But the second you try to take AI into the real world, you run into these two massive fundamental problems. And understanding them, well, that's absolutely essential if you actually want to build AI that works. Okay, so let's start with this question. In theory, an AI learns through trial and error, right? It tries something, sees what happens, and gets better. But what about in the real world? You can't have a self-driving car just crash a bunch of times to learn how to drive, or a medical AI testing random treatments on people. The stakes are way too high. The cost of one wrong move is massive. And this gets to the heart of the first problem, the huge difference between online and offline learning. Online learning is like you're in the driver's seat. You're actively exploring and getting constant feedback. But in so many critical real-world situations, we're stuck with offline learning. All we have is a fixed book of past data, and that's it. The AI has to learn everything it can from that book without ever getting to try something new. So this sets up our first major challenge. How in the world do you learn a great strategy when all you have is this one static batch of data? This whole area is called offline reinforcement learning, and believe me, it is a minefield of potential disasters. The single biggest danger here is something called overestimation. See, an AI's value function, its guess about how good an action is, often starts off as just random noise. So because of this randomness, it might look at an action that's completely new, something it has never seen in its data, and think, whoa, that looks like a fantastic idea, even when that action is the equivalent of driving straight off a cliff. It's dangerously optimistic about the unknown.
Right. So the million-dollar question is, how do you fix that? How do you rein in this wild optimism and teach the AI to be a little more cautious about paths it's never seen before?
And the answer is this really elegant algorithm called conservative Q learning, or CQL. The core idea is just so simple and powerful. It basically teaches the AI one rule: when in doubt, be pessimistic. If you see an action that wasn't in your data, just assume it's probably not a good idea. It actively penalizes the value of things it doesn't know. Here's how it works under the hood. For any action that it has seen in the data, CQL does its best to estimate its true value accurately. But for any action that's outside the dataset, it systematically pushes its estimated value down. The result is what we call a lower bound Q function. It's a conservative, safe estimate that stops the AI from chasing those crazy, overly optimistic pipe dreams. And this isn't just theory. This is really being used. The lecturer gave this fantastic example from LinkedIn. They used CQL to optimize their notification system. And by learning from just a static log of user data, they built a system that got a higher click-through rate while actually sending fewer notifications. I mean, that's a huge win-win.
Okay, so that's problem one, learning safely from a fixed book of data. But now we're going to pivot to what I think is an even deeper, more fundamental problem. What happens when the AI doesn't even have a clear goal to begin with? I mean, where do these rewards even come from?
Just think about this example for a second. Imagine you had to write the code, the reward function, for a robot to pour water into a cup. You'd have to penalize for any spillage, right? But also reward for speed and accuracy and getting the amount just right. It becomes insanely complicated to manually specify what good even means for such a simple task. So a first thought might be, okay, forget coding it. I'll just show it a bunch of pictures of good pours and bad pours and train a classifier. The problem is, a reinforcement learning agent is a relentless optimizer. It will find the weirdest, most unexpected ways to hack that classifier. It'll find some bizarre loophole that gets at the reward without actually pouring the water correctly. The solution to this is just beautifully adversarial. It's like a game. As the AI policy tries to find these exploits to fool the classifier, you take those very attempts and you feed them back to the classifier as new examples of what not to do. It becomes this constant cat-and-mouse game where the policy and the reward model make each other smarter, which prevents this kind of reward hacking.
But this whole process is still kind of clunky. What if we could do away with defining the goal explicitly at all? What if we could teach the AI what we want in a much more natural, more intuitive way? And this leads us to a really powerful idea, learning directly from human preferences.
And it all comes down to a really simple insight about people. Think about it. If I ask you to rate a robot's pour on a scale from 1 to 10, that's kind of hard, right? Your 7 might be my 8. but what if I just showed you 2 attempts and asked, was A better than B? That's incredibly easy for us to do, and our answers are way more consistent. This simple idea is the entire foundation for reinforcement learning from human feedback, or RLHF. Instead of us trying to write some complicated reward function, we let the AI learn the reward function just by watching which outcomes we prefer. It learns our values simply by observing our choices. The whole process breaks down into 3 main steps. First, you just gather a ton of data by having people compare and rank different AI outputs. Step 2, you take all that preference data and use it to train a separate AI called a reward model whose only job is to predict what a human would like more. And finally, step 3, you use that new, learned reward model as the goal for your main AI, and you fine-tune it with RL to get the highest possible human preference score. And here is the kicker. This isn't some niche academic concept from a lecture. This exact 3-step pipeline, gather preferences, train a reward model, and fine-tune with RL, this is the core methodology behind the state-of-the-art models we all use every single day, like ChatGPT. This is how it works. So let's just take a step back. What does this all mean for those of us who are on this journey of building and understanding AI? Why are these 2 solutions so incredibly important? Well, it really boils down to this. On one hand, you have offline methods like CQL, which give us the tools to learn safely and effectively from the kind of messy, limited data the real world throws at us. And on the other hand, you have reward learning, especially RLHF, which gives us this amazing way to align AI with our complex, nuanced human values, things that are basically impossible to just write down in code. Together, these 2 ideas are the bridge that takes AI from the research lab to the real world. And that really leaves us with one final big thought. We've figured out a powerful way to teach an AI to follow our preferences, to learn what we like. But the next and probably much, much harder question is this. How do we teach it our wisdom? How do we make sure it learns not just what we prefer in the moment, but what's actually good for us in the long run? And well, that's the challenge that lies ahead.